forward. Off. Okay, so these are kind of like, you can add these to your notes. Okay, if you already have the puzzle, you can kind of add at the end, or you can open them on a page if you'd like, as I go through all these. Okay, so let me make sure, pan over a little bit. Okay, so the triangle we're going to start with, we're just going to start with the ratios, is it's going to have 20, 25, ooh, that's my voice, and 15. So we're going to set up all the 6 different trig ratios. Okay, so we're going to do sine, cosine, tangent. Okay, we're just going to start with those first. All right, so first, or let me write this up here, kind of help us remember what side goes to what. Now, before I do set those up, we've got to remember what is what when it comes to opposite side and adjacent side and hypotenuse. Okay, so let's start with the hypotenuse. This hypotenuse will always be across from what angle?
Opposite.
What angle is it across
from?
From the 90-degree angle. So boom, there's your hypotenuse. Okay. Now let's say, oh yeah, I need theta. Okay, I need this little angle symbol here. By the way, that is a Greek symbol, and it's called theta. Okay, so if I say angle or theta, it's the same thing. Okay, that's what we're using as a reference point. Okay, besides the 90, which always tells us where the hypotenuse, this will tell us where opposite and adjacent is. So if I'm going across from the angle, what side would that be? Opposite or adjacent?
I think opposite.
It's opposite, yep. Opposite means across. Adjacent means right next to you. Okay, so adjacent is this side, it's the other leg. And notice how it's right next to that leg. It's adjacent. Okay, adjacent meaning close. All right. All right, so let's first start with sine. Sine, whoops. Sine is opposite over hypotenuse, meaning opposite 20 over 25. So 20 over 25. But I want to reduce that. I can divide those. All these numbers are divisible by what? 5, so reduce it. Okay, so divide by 5, I get 4 over 5. Okay, cosine, adjacent over hypotenuse. Adjacent, 15 over the same hypotenuse, 25. Reduce it, divide by 5, 3 over 5. Okay, last one, tangent, opposite and adjacent, opposite side, adjacent side, so 20 over 15. And then divide by 5, so 4 over 3. All right, then you have the reciprocal functions, or the cousins, as Ms. Menard says in the video, cousin functions. The cousin to sine is cosecant. The cousin to cosine is secant. And then the cousin to cotangent, I'm sorry, to tangent is cotangent. Now, if I had it my way to set this up whenever they decided these names, I would have made secant the opposite of sine and cosecant the opposite of cosine, because it's like, you know, C with C, S with S. But just know it's the opposite. So if you're trying to remember, I always know that S goes with S goes with C and C goes with S. Okay, whether it's cosecant or secant. Okay, so now as long as you know this one, sine, cosine, and tangent, these ones are just the exact, or like the reciprocal, they're opposite but flipped. So literally, cosecant is sine flipped 5/4. Which means, same thing for cosine and secant, 5/3. And then the last one would be what? For cotangent, 3/4. Okay, so 3/4. Okay, so as long as you know these ones, and then know which one goes with cotangent is usually the easy one to remember. Tangent, cotangent, because the names are pretty much the same. But you just got to flip them. And then sine goes to cosecant, cosecant goes to secant, and just, again, flip those, okay? So all that is a ratio. All you're doing is setting up a ratio. Okay, the next step is like actually looking for like missing sides and that sort of thing. Okay, now there are some special cases with this where you're gonna have to deal with radicals and square roots. So for example, let's do this one. Okay, we're gonna do cosine of a triangle, and this triangle looks like this. So it's kind of upside down, 2 and 5, and then we have theta. Okay, now we're only just looking for cosine right now, all right? So that means that I need the adjacent side and the hypotenuse. Now let's look at the triangle. Here's the angle. This side across from it, which side is that? It's the opposite side. But cosine, we don't want the opposite side, we want the adjacent side. The adjacent side is right here. The issue is we don't have that side, we don't have the length for it. So we have to find it. And then 5 is our hypotenuse. So in right triangles, what can we use to find missing sides?
Pythagorean theorem.
Right, Pythagorean theorem. So we got an extra step here to set up. We got to use our Pythagorean theorem first. A squared plus b squared equals c squared. Now, the 5 is which letter? Is it A, B, or C?
A.
Your hypotenuse is always your C. Because remember, this is leg squared plus leg squared equals hypotenuse squared. Your C is always your hypotenuse. So the other two are your legs. So which obviously it doesn't matter where they go. Okay, I can put, now let's say we call this one, I don't know, we'll call it B. Or it could be A. It can be either one. All right, so now 2 squared plus b squared, that side right there, equals the hypotenuse. Okay, so let's square that. So 4 b squared is 25. We got to get b by itself, so subtract. B squared equals 21. Last step, what do we do next?
Square.
Square root. Can we square root 21 and get a whole number?
No.
Yep. So you just leave it like that. So if you can't square root it, you can't even birthday cake. You can't even simplify it, because if I do birthday cake here, which in some cases you will, all I get is this. There's no group of 2. So I can't do anything with it, just leave it. All right, so that means that this side is square root of 21. Now again, going back to, we need cosine, which is adjacent over hypotenuse. So square root of 21 over 5. Now some of the problems are gonna be like that, but flipped. So let's just say I asked you for the secant for the same problem. What would be the secant for that? Remember, secant is the opposite or reciprocal of that. So what do I do with this to get the secant?
Wait. It's just so confusing because there's so much writing. You're asking for secant?
Yeah, so here we're down here now, right? We found B, we found that missing
So
side.
what is it? Is it
There's the ratio.
5?
You flip it. Okay, so there's your secant. What's the issue with that secant?
That the square root's on the bottom.
So now we got to rationalize. So some of these are going to ask you to rationalize. Okay. So I'm going to take this off to the side. What do I multiply on top and the bottom?
The square root of 21.
So whatever square root you have on the bottom, remember you just square root, you multiply that on the top and the bottom. So typically this number and the square root, you can't do anything with it, so you just leave it. I'm actually going to bring this back up here. Okay, so now 5 times the square root of 21 over, what's square root of 21 times square root of 21? It's just 21. Okay, remember it ends up being the same number. You just take away the square root. Okay. So point of that is, one, sometimes you're going to miss in the side. You got to find the side of the Pythagorean theorem. Okay, or after you've set up the ratio, you might have a square root in the bottom, and you have to rationalize. So I kind of did all those different things in one problem, so you can kind of cover all the bases, just in case you got to do that. Okay, and I'll show you guys in the packet which ones you need to do that with before we end our time. Okay. Last two, we're going to look at finding a missing side and a missing angle. Okay, so finding a missing side. Let's start with this one. Okay, so I've got 15 here. It says X there. You guys can't see the line. We're just a little bit, there we go. And then right here, we're gonna have 37. And we gotta find that missing side. So the only information you got is an angle and one of the legs. And we're looking for the hypotenuse. Now, what we need to do is decide which function, sine, cosine, or tangent are we going to use here. In order to figure that out, you got to know what sides do you have, or what are we looking for, and what do you have. So if that's the angle, which side is that? Is that adjacent or opposite? An opposite would be here, straight across. That's opposite, so that means the one right next to the angle, that's your adjacent side. Okay, so always look like if the number's across from it, boom, opposite. But if it's right next to the angle, that's your adjacent side. Remember, the one across from 90 is always your hypotenuse. Okay, so that means if I'm using adjacent, a hypotenuse, which function uses that? Is it sine, cosine, or tangent? Which of them has that? Let's write down SOHCAHTOA. So ka, to, ah. Well, which one? Cosine. Because if you look at it, adjacent and hypotenuse. Sine is opposite and hypotenuse, and this one is opposite and adjacent. Okay, so it's this one. So that's the one I'm going to use to find that missing side. And you do the same thing when you set your missing angle. So cosine of the angle is equal to adjacent over hypotenuse now you gotta solve.
Nothing goes under the cosine? Like when you're making it proportions, nothing goes under that?
There's
Or that would
nothing,
technically always.
you can put something under it to help you solve it. What could you put under it?
One.
A 1. So yes, so now you have a proportional equation, which now that we have proportion, what's the first step here?
Cross multiply.
Right. Cross multiply there. All right. Now there is a shortcut to proportions. If they are across from each other diagonally, I can switch them. So I can switch the x, put it right up here, and take the cosine and put it right down there, and then it's one step, 15 divided by cosine. Okay, but I'll show you how to do it kind of the long way. So now it's x times cosine of 37 equals 15. And then the last step is to divide by cosine of 37. And that's going to give me my answer. So 15 divided by cosine of 37. Like I said, you could do this. Just switch these. If they're diagonal, you can switch them. And if x ends up on top, well, that's it. Move that down there. All right, so now x equals, got the answer already, 18.8. The worksheet I have asks you to round to the nearest tenth. So if you do have to, I believe in the packet it asks you to round to the nearest tenth whenever you do these problems too. Okay. Now one more, you do the angle. So let's do this. Yeah, let's do this guy. Okay. So the angle we're looking for, I'm going to label it theta. So we're looking for that angle. That's the problem. All right. So first we got to decide, what do we have? Well, this side 22, is that adjacent or is it opposite?
Opposite.
Straight across. And then the 6, is that the hypotenuse or is that adjacent?
Adjacent.
It's adjacent. Okay, so the hypotenuse is right here. We're not using that. So that means that we're not using either sine or cosine because they both need the hypotenuse. We're using tangent, opposite over adjacent. Okay, so now tangent of theta, the angle, is equal to opposite, 22, over adjacent, 6. And now there's one step here. Okay, once you have your ratio, to find an angle, you use a different function. You guys remember what it is by chance?
Like that side angle side thing.
No, we're not saying angle side.
Wait. Finding the missing angles?
You use the inverse function. So tangent inverse. So when you put the little -1 there, that just means inverse. Kind of like the inverse functions you had to find in some of the packet problems. And what you do is you basically just switch this. Theta now goes to the other side, and your ratio comes to the other side with tangent. So now on a calculator or in Desmos, you do tangent inverse of 22 over 6. Okay. Now let me show you guys how to set that up.
Is theta necessary?
This could be whatever you want. This could be X. Sometimes, if they have letters, the question was, is theta necessary? No. But you got to label the angle something.
And you only use the inverse when you're finding this angle. So
Yes.
You use it for finding the side.
Yes, exactly. Only use the inverse when you're looking for an angle. Okay, so question was, is theta necessary? Not necessarily. And sometimes the problems you guys work on are going to have different labels. Maybe it'll say find missing angle B, right? So now it's tangent of B instead of theta. It just depends on what it's labeled. Okay, it could be labeled anything. Okay, so now when I do that, I end up with B equals 75 degrees. All right. All right, so let me show you all how to set that up. And then we'll go over, I think, a few things in the packet. Let's see, pause for a second. Okay, so let's say I'm doing like that last one, which was tangent inverse of 22 over 6. Okay, or the one before that, which was 15 divided by cosine of 37. All right, when you do this on a phone calculator, you need to do, like say this one, for example, you need to do the sine part or cosine part first. So what I want to do is hit 37 cosine. Then I'm going to have to take that, like basically write that number down like in my head and do 15 divided by that. Okay. Again, this is why I like to do everything on Desmos, because you can just set it up all in one step. Okay, and then I have to divide. And you notice I end up with a different value because I had to round it. So the actual answer I got before was 18.8, but near I got 19.7. So again, I just encourage you guys to either download the app, which you can also download on your phone, or just use your computer. And then tangent inverse, do the same thing. You want to enter the value first. So 22 divided by 6 in this case, it's going to turn into a decimal. And then I hit the tangent inverse button down here. Oops, I didn't do that. Okay. Oh, you know what? It's in radians. So I hit degree mode. Oh, see, this is extra complicated. Just use Desmos. You have to make sure you're in like, see how it says rad? So radians is a different type of angle measure. You have radian, kind of like you have meters and feet. Radians is another way to measure angles. So now you got to like make sure you click degree. Now to do 25 divided by 6. Okay, this isn't working. I just recommend using Desmos. I'm going to have to figure that out. I actually don't know how to do inverse on there now. All right, let's figure it out later. All right. Okay, so last thing, I just want to go over some things in the packet to help you guys out. If you want to take those out, section 9.2. Okay, so the first 6 problems that you guys do on here, you are just using the basic ratios. When you get down here, you're going to have to rationalize, meaning you're going to have to get rid of that square root on the bottom. So here and here. The last one down here, you're going to have to, these last 2 on the bottom, you're going to have to find the missing side and use a squared plus b squared equals c squared. So you got to do that first before you set up your ratio. Okay, then on the back page, now I have your notes open with like your ratios on the side as you're going with them or through those. Okay. This one, you're also going to have to find the missing side. And rationalize. So this is kind of a combination of the two, kind of like that one example I showed you guys on the board with the secant. Okay, I'm going to go over this one with you guys real quick. So this one, you're sketching a graph. Okay, so it's kind of like what we did when we started class. Okay, we have to figure out the roots. So first of all, what are the roots? What are the x-intercepts? Pablo, what's one of them? Okay, you got -2. What's another root? Okay, +2. Diego, what's the last one? Well, I have 2 and -2. That came from these two, but what comes from x squared? 0. All right. Now notice, guys, all of these have what on them? Samir, what do you notice?
really small, but is it zero?
Is a squared. What does that mean? All of these roots are?
Double.
They're all doubles. Meaning they all do what on the graph? They all bounce. They all bounce, okay? Now, does anybody remember what negatives do to functions? What do they make them do?
What negatives do to function?
Yeah. Decrease, it makes them point down. So the negative is going to make it point down. Okay. Next question I have for you is, what is the degree of the function? No. I've got 3 roots, but they're all what? What kinds of roots? They're all double. So that means how many for the degree? So each of these counts as 2. So that means degree is 6. Because you double each of these because they're double roots. Okay, so because I got 1, 2, 3, I double it, which means for the terns, because remember terns is a little bit different. How many terns would it have? The degree of 6. 5. Remember the terns is always 1 less. Okay, so we can use that information now to figure out what it looks like. Well, we know it's pointing down, so I'm going to start with it pointing down. It's going to turn 5 times. 1, 2, 3, 4, and 1 last turn, 5. And notice it points down on both sides because I degree of 6, 5 turns. Now, all these roots are going to do what? They're all going to bounce, meaning that it cannot cross through the x-axis. So would this be below the x-axis, or is it going to be above? It's going to be below, especially if it's pointing down. And they all bounce. Now we know the roots. Where will it bounce first on the left? At -2. Then Samir, where's it going to bounce next? At 0. And then Diego, what's the last one it's going to bounce at? At 2. So now you can use that info to sketch your graph out, okay? All right, this last one, you can use 30, 60, 90 like yesterday, guys, to figure that out. This one, you can use the 45, 45, 90 like yesterday. And then the last one here, imaginary numbers. All you guys are doing here is A represents this whole expression, so 2 plus 3i. And the first thing you're doing is adding those two together. So the B is 1 minus I. And then you do the same thing here, except you're going to subtract. And then the last one, you are going to multiply. Now, when you subtract, what do you need to do first? What's unique about this compared to that one? What do we got to do first before I distribute? So remember, don't forget to distribute that negative first, guys. And then the last one here, we're going to multiply. So what can we set up to multiply? What can we use to multiply this? The box. For some of you guys, use different things like the T or your foil, whatever you use, okay? All right, you guys are online on Zoom. You guys are good to go. That's it, unless you guys have questions for me or you need help with something. Oops, sorry, guys. That's it. I'll see you guys tomorrow. You guys, I want you to work on the first page. So turn to the first page, and I want you guys to get started with that. Oops, forgot to stop recording.